Thank you, viewers. This is Mr. Dingo, and once more I want us to start a new chapter. And today we are going to look at Surds. Now, Surds is a very small chapter, but very important in mathematics, because sometimes we want to write a very long decimal number into an exact form of that number. And in that case, if, for example, we are to get Surd 2, or square root of 2, the answer we can say 1.414 rounded off to 3 decimal places. We realize that if we write Surd 2 or square root of 2 as 1.414, that is not Surd 2. That is a number that can actually be a rational number. So sometimes we have to maintain the accuracy or the integrity of the number by ensuring that that number is written in its exact form. And what a better way than using surds. So we say that surd is a square root of an integer that is not a square number. It's a square root of an integer that is not a square number. We realize that 2 here is not a square number, 19 is not a square number, 5 is not a square number, 2 is not a square number, 2 here is not a square number. There are many other numbers that do not have square roots, but these are just a few examples that we have there. So realize that if you get the surds of all these numbers we indicate here, we are going to get a very long decimal. If you expand it to a very long decimal without actually an end, and that number, it is not repeating. I know some of us will say, if it's a recurring decimal, then why don't we just use method of converting recurring decimals into fractions? These are not recurring decimals where we have repeating numbers so that we can be able to convert it. They are not repeating numbers. If you see, for example, Surd 2 is 1.414, like that, and this dot's meaning that that number is still continuing. If you have a calculator that can show many digits, we are going to have that number continuing that way. And sometimes if you want to confirm that a number is actually irrational number, when you get Surd 2 in a calculator, when you put Surd 2 in a calculator, and you get the answer there, if you try to press the button for fraction here, you realize that that button for fraction, even if you press it, that number is not going to change into a fraction. That is an indication that that number is irrational. And one of the irrational numbers that we have is pi. Pi is also a irrational number, but not a surd. So we are saying that surd is a very important area of study. So we say that these irrational numbers, we cannot convert them into rational number. Rational number is a number that can be written in form of 1a over b, where a and b are integers. Like I've just said, Surd 2 is 1.4142135662. If I press the button for fraction to be able to change it in this form here, it doesn't change. That means that that number is irrational. So there are numbers here, Surd 4, Surd 25, Surd 16. We realize that this 4, 5, 25, 16, these are square numbers. These are square numbers, but we said surd is the square root of an integer that is not a square number. So therefore, Surd 4, Surd 25, Surd 16 are not surds. Because, for example, if we said Surd 4 is 2, 2 can be written as 2 over 1. And when we write 2 over 1, we know that actually that was Surd 4. Surd 4 can be expressed into 2 over 1, meaning a over b. So Surd 4, Surd 25, any surd of a square number is not called a surd. Now, there are rules here we can use to be able to manipulate these surds. And one of the rules we are going to use is that if we have a number a, surd a times b, then you can say it is surd a times surd b. That is very, very important for us to see there. So it means that if I have a number, the surd of 6, that means that we can express this surd 6 into something like a times b. So I can say surd 6 is the same as surd of 2 times 3. Viewers, I think that is making sense. If I have surd 6, I can be able to express it in this form that we have here, where now I can say a is 2 and b is 3. And after we have this, then it means we can therefore say this is the same as surd 2 times surd 3. So these are one of the rules we are going to use to be able to manipulate surds to achieve a result that is desirable. Another thing we can also have is if we have a surd of 2 divided by 3. If you have a surd of 2 divided by 3, surd 2 over 3, that can be written as the surd of 2 divided by the surd of 3. So those are some of the rules we are going to use in our ways of determining the required result during evaluation of surds. So very quickly, I want us to start with the very basic thing about surd, which is simplification of surds. Now, we can't go on with surds if we can't be able to simplify, because many questions will be simplify as far as possible, expand and simplify. Rational denominator, which involves a lot of simplification in it. So simplification of surds becomes the first part of our study today. So let's go directly there. So simplification. And when you are going to simplify surds, those 2 rules we have talked about must be used. So simplifying surds. So let's see how to simplify surds, and let me say example. Our example 1 is just simplify. So what do we simplify? Let us say simplify a surd 12. Now, when we are told to simplify, sometimes it sounds like, what do we have to simplify here? Because there's nothing to divide with another, there's nothing to multiply, there's no bracket to open. But we have to see that surd 12 here carries a number. It can carry a number with a square. 12 is a result of 1 square number and 1 non-square number. Now we have to look at what is that square number. That's the most important to us. And sometimes this is what I do. When we are told to look for that square number, just start dividing this number by 2, 3, 4 until you get the other number, the result of the quotient that is a square number. So if I take 12 divided by 2, I get 6. 6 is not a square number, so it means I'm not there yet. Let me go to 12 divided by 3. I get 4. So you realize 4 here is a square number. Now I can simply be able to say that if I multiply 3 by 4, I will get 12 that we have here. So it means that from the first rule we talked about, rule 1, I can say surd 12 can be interpreted to be 4 times 3. So I have surd of 4 times 3. Surd 4 times 3. Now this 4 times 3, using the rule 1 that we have talked about, will simply be the surd of 4 times the surd of 3. And viewers, be sure that I try to do something here. I try to make the number with the square number be appearing first, and then the non-square number second. Why? Because once I get the surd 4, we said surd 4 is not a surd actually, because it's a rational number. Once I have that, it's going to be the coefficient of the surd of 3 here. So I don't want it to be on the other side. So if I move down here, we'll have to say surd 4 is 2, so that is 2 times surd 3. And 2 times surd 3 can simply be written as 2 surd 3. Because that is basically easy. It's just playing around with these numbers. B, let's see if you are told to get surd 27, the surd of 27. So the surd of 27, just like I said, let us look for a number that if we divide 27 with, we are going to get a square number. And like I said, let's take 27. 27 is an odd number, so therefore I can't divide it by 2. Let me start dividing it by 3. If I divide 27 by 3, I get 9. There. So 9 here is our square number, meaning that if I multiply 3 by 9, I will get 27. So what I simply come here and do is to say this is going to be 9 times 3. Like I said, let's separate them by saying surd 9 times surd 3. But surd 9 is 3. So we are going to say 3 times surd 3, which actually becomes 3 surd 3. That is our the simplest form of that number. Let's look for part C. Part C is surd 80. Surd 80. Surd 80 here is a number like these other ones. If we want to be able to simplify, the first thing, like I said, let's take that number 80 divided by 2. We get 40. 40 is not a square number, so we leave it. Let's take 80. It's an even number. Divided by 3, I'm going to get a decimal. So let me skip 3. Let me go to 4. If I divide this by 4, I get 20. 20 is not a square number. Let me move to 5. 80 divided by 5, sure, is 16. So we have our number there. 16 is a square number. It means that SAD 80 can also be written as 16, SAD of 16 by 5. We know that the two numbers I have to get here, one is a square number, one is not. That's how you should think. There's no way you are going to get two, for example, saying, let me say SAD 4. I know someone will take 4 here. 4 is a square number here. What about if you take 4 times 20? I want you to believe me here, viewers, that yes, I agree with you, 4 is a square number, so we can as well say SAD 80 is the same as SAD 4 times 20. But this 20 here can also be written as 4 times another 4 times 5. So viewers, you see that this one would not give you the correct answer. If you come here and say that the square root of 4 is now 2 SAD 20, this will be wrong because this can be simplified further. So the best number is that let us get the biggest square number. Let me use that word, the biggest square number. Here 4 is not the biggest square number, but 16 is. Just like we have 4 times 4 here will give us 16. So when we come here, we say this is SAD 16 times SAD 5. And therefore SAD 16 is 4 times SAD 5, which we can simply say 4 SAD 5. You realize that we are talking about things like algebra, where you can say 4x, 4y, 3t. This one is like just a letter in algebra, which we are talking about this 4 as the coefficient. Let's look at another example. What about if we have 3? 3 is, or D is 3 SAD 48. You realize that now we have a number, the coefficient of a SAD here, and then we have 1 in the SAD form there. So let's just leave this one out of it and factorize this one first. 48, like we have said, 48 divided by 2 will give us 24. 24 is not a square number. What about 48 divided by 3? 48 divided by 3 is 16. Yeah, 16 is a square number. So we can say that this one can be written as 3, this 3. Then we have 16 by 3. Therefore, when we separate with rule 1, we'll say this is 3 times SAD 16. Let me say this is 3 times, then times SAD 3. So this will be 3 times SAD 16 is 4 times SAD 3. So this will be 4. 3 times 4 is 12. So you can say 12 SAD 3 is the simplest form of that problem. What about if we have SAD 20, that is E SAD 20 over 2. SAD 20 over 2, someone is thinking, let us apply rule 2. This one still will not work with rule 2. Let's just deal with the numerator, which we said 20 divided by 2 is 10. 10 is not a square number. What about 20 divided by 3 is going to be a decimal? Let's go to 4. 20 divided by 4 is 5. So we are going to say 4 times 5 there. So we'll say this will be SAD of 4 by 5, but we know everything is divided by 2. Then from there, rule 1, we know we can have SAD 4 times SAD 5, everything divided by 2. But we know that SAD 4 is 2, so we are going to have 2 times 5 divided by 2. But we know that this 2 here goes here 1, it goes into this 2 1 times. This one SAD 5, sorry. So 1 times SAD 5 will simply be SAD 5 as the answer. So viewers, that is how you deal with these particular cases. And let's move to another part F, part F, 1F. So F here is SAD 294. SAD 294. Which number will go into this SAD 294 by giving us one square number and one non-square number? Let's just start by 2. So 294 divided by 2. I want you just to follow that step. When you are starting this thing, don't be in a hurry. So 2, if you divide this by 2, 2 times 147. 147 is not a square number. Let's go to 3. 294 divided by 3 is 98. 98 is still not a square number. So let's go to 294 divided by 4 is 73.5. No. Let's go 294. 5 cannot divide it. Let's go to divide by 6. We get 49. Good. So we have two numbers here. The two numbers we have is 294 can also be written as 49 times 6. 49 times 6, we know we can write this one as SAD 49 times SAD 6. And SAD 49 is 7. So 7 times SAD 6 will be 7 SAD 6. And we have simplified the SAD of 294. Viewers, I believe by using those concepts we have followed through, you are able to answer a few questions involving simplification of SADs. I want to give you questions that I expect you to be able to try yourself with, so that you know whether you know or you don't know. And the exercise I want to give you here is, the exercise is simplify. 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 Number 1 is SAD 50. I believe that is very easy. SAD 2. Number 2 is SAD 243. Three is SAD 275. 4 is SAD 147. 5 is 4 SAD 125. And 6 is 28 SAD 28. And finally, number 7 is SAD 180. SAD 180 divided by 2. So viewers, this is what I have for you. You try these questions so that we can tell whether you know what to do or you actually do not know. The next part of our lesson today will be addition and subtraction of SADs. Now that we have understood how to simplify SADs, we really have to know if you have cases of SADs being added, how do you really go about that? And we are just going to follow the concepts of algebra, how you add x plus x or 2x plus 3x. So if I have an example like example 1 or A, 2 SAD 2 plus 3 SAD 2. I want you to assume that we have the SAD 2 here. The SAD 2 here and another SAD 2 here. Let us compare them with something if you have 2x plus 3x. Where now we are using this x here to be like our SAD 2 and here is SAD 2. In other words, these terms are like terms here because we have SAD 2 and SAD 2. It means we can be able to add them together. If you have this particular issue to deal with, the first thing is to know is that you just have to add the coefficients 2 plus 3. So the answer here will be 5 SAD 2. Just like you would add 2x plus 3x and get 5x. But if these terms are not the same, then it means you cannot add them because therefore we don't have our like terms. Let us see example B, which is 10 SAD 3 minus 2 SAD 3. So 10 sad 3 minus 2 sad 3. Just like addition, we are going to do the same with subtraction. The only thing you need to know is that this is the same as like if you have 10x minus 2x, so that you will be able to have 8x. But now in this case, x here represents something like sad 3. So we can say that if you have 10 sad 3 minus 2 sad 3, this will just be 10 minus 2. The result is 8 multiplied by sad 3, which is going to be here 8 sad 3. This is quite easy. C, if you have 12 sad 5 plus 5 sad 3 plus 2 sad 5 plus sad 3. We have a much longer problem, and if you have look at this thing here, let's collect like terms. Sad 5 and sad 5 will come closer to each other, so we'll have 12 sad 5 plus 2 sad 5. What I'm just going to do, we're doing here is just collecting like terms, like you have 12x plus 5y plus 2x plus y. So we are collecting the like terms, see sad 5 and sad 5, then plus 5 sad 3, bring together with the sad 3. So that will be sad 3. So if we add here 12 plus 2, because I said if you have this and this, what you need to add is this coefficients. 12 plus 2 is 14. 14 sad 5 plus. This is 5 sad 3 plus sad 3. If it is sad 3, it means it is 1 sad 3. So we can say there is a silent 1 there. So if you have 5 sad 3 plus 1 sad 3, we expect to have 6 sad 3. We cannot continue beyond this level because these are now unlike terms. Sad 5 and sad 3, they are not the same, so we cannot be able to add them. So our answer is that. Question D is 5 sad 3 plus 2 sad 7. You realize that this problem here, this is its answer, because this is sad 3, sad 2, sad 7, sorry, sad 3, sad 7. Sad 3, sad 7, they are not like terms. So this is our answer. We leave it like that. We cannot simplify it further than that. E is 15 sad x plus 17 sad y minus 8 sad x minus 12 sad y. So let's collect like terms, sad x and sad x. So we'll say 15 sad x minus 8 sad x plus 17 sad y minus 12 sad y. So here, if we subtract 15 minus 8 is 7. So 7 sad x plus 17 minus 12 is 5. That is 5 sad y. Sad y and sad x are not like terms, so therefore this is where we stop. I want us to go to number 2, which is also simplify. So example 2 will still be simplify, and in this case part A of the question is 175 sad 175 plus sad 63 plus 2 sad 28. Now viewers, you realize that we are having a much more trickier example than example 1, which simply required us to add or subtract, where these are already in the simplest form. In this case, someone may think that these are unlike terms, and therefore the answer remains sad 175 plus sad 63 plus 2 sad 28. But I want us to remember what we did in our lesson, the first part of this lesson, which was simplification of sides. Can we be able to simplify sad 175? And if we can do that, then can we see something there that now it's going to look like in this particular form when it is in the simplest form? And let's see that. If I look at side 175, I said side 175 we have to simplify by probably 25 times 7. So 25 times 7 is 175. So I can say 25 times 7, that is that, plus 63 should be 9 times 7. So 9 times 7, so 9 times 7, plus 2 into 28 is 4 times 7. So viewers, you see, we have the non-square number is 7, 7. It means at the end of the day, we are going to get surds with all like terms. So this is, if I do this, it's going to be surd 25 times surd 7 plus surd 9 times surd 7 plus 2 times surd 4 times surd 7. So surd 25 is 5. 5 surd 7 there, plus surd 9 is 3. 3 times surd 7 is 3 surd 7, plus surd 4 is 2. 2 times 2 here is 4. So therefore we have 4 surd 7. We also realize that now we have like terms, all of them. So therefore the term surd 175 plus surd 163 type plus 2 surd 28 all simplifies to this, and therefore we can see surd 7, surd 7, surd 7. So we can actually add the coefficients 5 plus 3 plus 4. 5 plus 3 is 8 plus 4 is 12. So we are going to have 12 surd 7 as the final answer. Now viewers, realize that one is much more demanding than the first example that we looked at, because you have to go through 2 stages. First, simplify individual surds. After doing that, then you go forward to either add or subtract. Let us go to example B, which is surd 20 plus surd 80. And like I said, viewers, you can assume that because this is 20, this is 80, they are not like terms, that's the answer. No. You must only conclude that way if you reach the final stage or by simplifying the individual surds. In this case, we have to simplify surd 20. Surd 20, the square number here is only 4. That is 4 by 5. So the surd of 4 by 5 plus, we have seen 80 before, and we know that it is 16 by 5. So these are the numbers if you simplify them, and therefore we know that surd 4 in this case is, I can simply now go very directly without following this step here. I can simply jump by saying the square root of 4 is 2 surd 5. So I'll say this is 2 surd 5 plus this is 4 surd 5. If I add 2 surd 5 plus 4 surd 5, that will give me 6 surd 5 as my final answer. C, question C is 28, surd 28. So 28 minus 2 surd 63 plus surd 7. So in this case again, we know that 28 can be written as the surd of 4 by 7 minus 2. Surd 63 can be written as surd 9 by 7. And finally, surd 7 cannot be simplified further than that. So if I do what we did that time, we say this will be 2 surd 7 minus surd 9 is 3. 3 times 2 is 6. So 6. Surd 7 is just surd 7 because it can't be simplified. Then finally, surd 7. So if we do this work, we know that 2 minus 6 is minus negative 4. Negative 4 plus 1, because I said if it is surd 7, then there must be a silent 1 there. So we can say 2 plus 1 is 3. 3 minus 6 will be negative 3. So we have negative 3 surd 7 here as the answer. Let us see another example. Let us see another example. The other example here is 12, that's D, 12 or SAD 12 plus 3 SAD 48 plus the SAD of 75. Now let us move forward again. We know 12 can be expressed as 4 times 3. So I'll say 4 times 3. And I know someone may be wondering, where do we get this 4 times 3? If you are still having issues with that problem, you go to the first lesson where we were dealing with simplification of sides and what we have to do. Then plus, this will be 3. SAD 48 is the same as the SAD of 16 by 3 plus SAD 75 will be SAD 25 by 3. So if we do this, SAD 4 here is 2, SAD 3 is 3, so it will be 2 SAD 3 plus SAD 16 is 4. 4 times 3 is 12. SAD 3 remains SAD 3 plus SAD 25 is 5. SAD 3 is 3. So we see we have 3, 3, 3. Let us now add them. 2 plus 12 is 14. 14 plus 5 is 19. 19 SAD 3. So viewers, these are some of the questions that you may meet in your problems dealing with SADs. How to add, subtract, or sometimes you are required to first of all simplify before you can be able to add or subtract. Let us try this exercise. This is your exercise. Try this exercise and it is simplify. Simplify. And the exercise here one is SAD 200. SAD 200 plus SAD 18 plus minus SAD 72. Minus SAD 72. Number 2 is SAD 80 minus 2 SAD 20 plus 3 SAD 45. So viewer, try these two questions and see if you are understood what lessons we have taught today. And if you have any problem, please be sure to contact us so that we can be able to help you. Now I want us to go to another area, which is multiplication of sides. Multiplication of sides is also very, very simple. Multiplication of sides. So we have here multiplication of sides. Now multiplication of sides is simple, and let's just look at example and see how do you handle multiplication of sides. So let's say 1, let us say expand and simplify. So number A here, or number 1A, if I have 2 in bracket 3 minus SAD 2. So viewers, if I have this problem to deal with, where we are told to expand and simplify, you realize that you are told to simplify after expanding. So it means that my expansion, meaning multiplication, has to come in, because we know if you have a number 2 here multiplying 2 minus 2 in bracket, then the number 2 must multiply 3 and must also multiply SAD 2 here. So if I have 2 times 3, that one you know is 6, minus 2 times SAD 2 will just be 2 SAD 2. I said that SAD 2 is like x, so if I say 2 times x, it's 2x. But if I have SAD 2 here times 2, it is 2 SAD 2. Don't say SAD 2 times 2. These 2 must be the coefficient, so it must appear first. What about if I have b here, SAD 3 into 4 minus SAD 2 in bracket. In this case now, there we have an unsad number multiplying bracket with SAD, but now here we have the SAD opening the brackets here. So what do we need to do here? SAD 3 times 4 will be 4 SAD 3 because it is 4 times SAD 3. I said the number without SAD is the coefficient. It has to appear first. So it will be 4 SAD 3 minus. We realize that SAD 3 times SAD 2 is going to be something like this. SAD 3 times SAD 2. But we realize that this kind of operation, we have looked at it before in the rules. It actually falls under rule 1, where we say if you have two SAD numbers multiplied, then you can as well say it is 4 SAD 3 minus the SAD here having 3 times 2. This one we have seen before. So we are going to have 4 SAD 3 minus the SAD of 6. That is what we are going to have in that particular case. What about if you have example C? And example C is 5 SAD 5 into 3 minus SAD 3. Right, so this is what we have. Just like that one, we are going to multiply 5 times SAD 5 times 3 is 3 SAD 5. I'm saying 3 SAD 5 because I don't want to say 5 SAD 3. That will force me to say SAD 5 times 3. But by bringing this 3 here, we just have to write 3 SAD 5 without having to indicate multiplication sign. Minus 5 times SAD 5 times SAD 3. What did we do here? We can see that it was actually now the numbers multiplied under the SAD. So we are going to have 5 SAD 5 times SAD 3 being the SAD of 5 times 3 here. So we can actually say 3 SAD 5 minus SAD 15. There. So what about if you have D, which is SAD 3 or 2 SAD 3 into 5 minus 4 SAD 3. Good. So let us see. This number here, 5, can only affect this 2, not this SAD here. So if you have 2 times 2 SAD 3, then it's going to be 5 times 2, which is 10, then SAD 3. So here, this 5 I said can only multiply 2. So it will be 10 SAD 3 minus, again here we have 4 SAD 3 and 2 SAD 3. 4 can multiply 2, SAD 3 will multiply SAD 3. So if 2 times 4 is 8, and then SAD 3 times SAD 3 we have said is going to be the SAD of 3 by 3, which is going to be 10 SAD 3 minus 8 SAD 9. But we know SAD 9 is actually a square number, so it means SAD 9 is a rational number. So let's go get that rational number, which is 10 SAD 3 minus 8 times 3. So we know that's going to be 10 SAD 3 minus 24. But sometimes we like writing the answer in form of A plus B SAD C. You are going to see this form very often. So if you have this form there, it means that this 24, negative 24 here, is our A. So we have to bring it, and 10 is B and C is 3. So if that's the case, let's just rearrange so that we have negative 24 plus 10 SAD 3. That is what you have, where A is negative 24, B is 10, and C is 3. Viewers, let us go to example 2. Example 2, which is now going to be a little more challenging. You realize that expanding these things is much more easier. It's just like dealing with algebra. If you understand algebra very well, SADs should actually be easier, just like A, B, C. So if we have 2 minus sad 2 into 2 plus sad 2. We have now the example 1, we had numbers only one bracket. Now we have two brackets, and just like we deal with algebra, don't worry, let's rearrange this number so that we be able to expand it. We know we can use this one to expand this, but if you are also very tricky, you realize that this is just like a difference of two squares, where you can simply multiply 2 by 2 is 4 minus sad 2 by sad 2, which is actually going to be 2. But let us go the long way so that we see. This is 2. I'm using this one to expand this, so it's going to be 2 into 2 sad 2 minus sad 2 into 2 plus sad 2. That bit we know. It's like you have 2 minus x into 2 plus x. So this is what you do when you are expanding. 2 times 2 is 4 plus 2 times sad 2 is 2 sad 2 minus 2 times sad 2 is 2 sad 2, then minus sad 2 times sad 2 is actually going to be sad 4. That part I think we know, because I said if you have a number, as two sads number multiplied, that is the same as the sad of the product of those numbers. So sad 2 by sad 2 is going to be the sad of product of 2, and 2 is 4. So if you go further, this is 4 plus sad 2 minus 2 sad 2, actually that is 0 here. So we have minus there, because we said this 2 here will give you 0. 2 sad 2 minus 2 sad 2. 2 minus 2, 0. 0 times sad 2 is just 0. What about this one? Is sad 2. We are going to have that, which is finally going to give us 2. That is what we get if we expand that particular bracket. What about if we have, this was 2a, what about 2b, which is 5 minus sad 3 into 1 minus sad 3. So this is another problem that we have. Let's expand it the way we have done that. That is 5 into 1 minus sad 3 minus sad 3 into 1 minus sad 3. What I've done is I'm using this one to expand the other one, which is that one is there. So 5 times 1 is 5, minus 5 times sad 3 is 5 sad 3, minus sad 3 times 1 is sad 3, or 1 sad 3, then minus times minus is plus. So we get plus sad 3 times sad 3 is the same as the sad of the product of the numbers, which is sad 3 times sad 3 is the same as sad of 3 times 3. So we have 3 times 3 here. So this is going to be 5 minus negative 5 minus 1 is negative 6 sad 3 plus, this is sad 9. So we know that 5 minus 6 sad 3, sad 9 is the same as 3 because it's a rational number. So we can therefore say 3 plus 5 is 8 minus 6 sad 3. So actually we have also written the answer in form of A plus B sad C, where A is 8, B is negative 6, and C is 3. Well, let's go to example 3 in this case, which is part C, which is 2 plus 3 sad 2 squared. So if you have to deal with this, the first thing we have to do is to write in let's show in an expanded form, which is 2 plus sad 3 sad 2 into 2 plus 3 sad 2. So if you open this bracket, it'll say 2 into 2 plus 3 sad 2 plus 3 sad 2 into 2 plus 3 sad 2. So in this case, 2 multiply 2, we get 4, plus 2 times 3 is 6 sad 2, plus 3 Sud2 times 2 is 6 Sud2 plus, we have 3 Sud2 times 3 Sud2. So 3 times 3 will be 9. Sud2 times Sud2, we know that will give us Sud4. So this will be 4 plus 6 Sud2 plus 6 Sud2 is 12 Sud2 plus 9 Sud4 is 2. So 2 times 9 is 18. So if you have 18 plus 4, we'll get 22 plus 12 Sud2. This is going to be our 2 plus 3 Sud2 squared in its simplest form. Let's look at D, which is 3 minus 5 Sud2 squared. So in this case, we are going to have 3 into 3 minus 5 Sud2 minus 5 Sud2 into 3 minus 5 Sud2. So if you open this, we'll get 3 times 3 is 9. 9 minus 5 times 3 is 15 Sud2 minus 5 times 3 is 15 Sud2 plus negative times negative is positive. 5 times 5 is 25 Sud2 times Sud2 is Sud4. This will be 9 minus 15 minus 15 is 30, negative 30 Sud2 plus Sud4 is 2. 2 times 25 is 50. So we have 50 plus 9 will be 59 minus 3 minus 30 Sud2. If you write the Sud in the form of A plus B Sud C. So viewers, you have seen how to expand different brackets, and this is a fairly easy thing to do. There are no tricks here. You just have to do it. If you deal with how you expand brackets, just like someone can tell you 3 plus x squared, then the way you expand that one and simplify is the exact way you deal with this one, handling the Sud as the unknown in algebra. So please, you can try the following questions. You can try the following questions and see if you understand the concept. So viewers, those 4 questions are enough to be able to indicate to you whether you know what we have learned about expanding or multiplication of Suds. Now we have so far looked at, the first thing we looked at was simplification of Suds. The second part we looked at addition and subtraction of Suds. Now this lesson was about the multiplication of Suds, and we have seen how we can multiply Suds and also expressing Suds in the form of, or a manipulation of Suds or multiplication, which leads you to the expression of form of A plus B Sud C.